Hello students, in the previous class we had learned the Maclaurin's expansion and a function, that is we have solved a problem using Maclaurin's function. And today let's learn a few more problems on the Maclaurin's expansion, that is obtain the expansion of f of x equals x divided by sin x up to the term containing x to the power of 4. Observe here, the function is given as x divided by sin x, and you have to expand the terms up to x to the power of 4. So first, before going to this, as we have learnt in Taylor's series that if a function is given in terms of f of x, for our convenience we can replace this f of x by y of x. So in solution we will write f of x as y of x equals x divided by sin x. So here y of x equals x divided by sin x. Already we have learned that when sin x is expanded using Maclaurin series expansion, we will get as sin x equals x minus x cubed by 3 factorial plus x to the power of 5 by 5 factorial. Now coming to this here, y of x equals x divided by sin x you have, right? So what I will do, y of x as it is, then numerator, what do you have? X as it is, sin x is in the denominator. When sin x shifts to numerator, it becomes sin x whole inverse. Your function becomes y of x equals x into sin x whole inverse. Already we have the formula of sin x, which is solved by using Maclaurin series. So your equation becomes y of x equals x into, in place of sin x, what we will do? We will substitute the value here, that is x minus x cubed by 3 factorial plus x to the power of 5 by 5 factorial minus so on whole to the power of minus 1. So observe this term, the term inside the bracket, and this term when you take only the x outside from this inverse of the bracket, you will get x into x inverse, that is it will be in the form of x equals x inverse, x into x inverse equals, already you have taken x here, and this inverse minus 1 power is from here, this as we have the whole inverse power, so this x inverse, x from the bracket, and the inverse power as it is for the whole bracket. So x into x inverse, this what you will be having inside the bracket, so 1 minus x square by 3 factorial plus x to the power of 4 factorial, x to the power of 4 divided by 5 factorial minus so on. So as you know that x into x inverse is 1. So what happens? So what you will do here, y of x equals x into x is 1. So 1 minus x square by 3 factorial plus x to the power of 4 by 5 factorial minus so on whole to the power of minus 1. So what we will do next, in the next step, what we will do is we will take minus sign common, that is y of x equals 1 minus of x square by 3 factorial minus x to the power of 4 by 5 factorial minus so on whole to the power of minus 1. Already we know that what we have a formula. What is that formula? 1 minus x whole to the power of minus 1 is equals to 1 plus x square plus x cube, 1 plus x plus x square plus x cube plus so on, 1 plus x square plus x cube, so on, this is square, 1 plus x square plus x cube and so on. So now what this term becomes, it is in the form of 1 minus x whole square. Consider this x square by 3 factorial minus x to the power 4 factorial, treat it as x, so it becomes 1 minus x whole to the power of minus 1. So now apply the formula of 1 minus x whole to the power of minus 1. What becomes? 1 plus, what is x here? 1 plus second term is x in the sense the bracket term, 1 plus x is x square by 3 factorial minus x to the power of 4 by 5 factorial minus so on. Then what is after x, what do you have? 1 x. After x, what do you have in the formula? That is x square. How do you write that? X square by 3 factorial minus x to the power of 4 by 5 factorial minus so on whole square plus so on. Then observe here, y of x equals, so in the question they have asked you that obtain the expansion of the function f of x equals x by sin x up to the term containing x to the power of 4. What does this x to the power of 4 indicates? X to the power of 4 indicates that you have to select the terms of x from the bracket which has the power for x 4. So it becomes 1 plus x square by 3 factorial minus x to the power of 4 by 5 factorial. From this bracket, what? X square can be taken common, that is x square by 3 factorial, x square whole square it is. So it becomes x to the power of 4 by 3 factorial and so on. So here observe here, then this term can be written as 1 plus x square by 3 factorial minus x to the power of 4 by 5 factorial plus x square by 3 factorial whole square. This like x by 3 whole square. So the term when you expand this become 1 plus x square, 3 factorial is 6 minus x to the power of 4 by 120 plus x to the power of 4 by 3 factorial is 6, its whole square, 6 is 36. So it becomes, when you take LCM for this, it becomes 1 plus x square by 6 plus 7 x to the power of 4 by 360. See here 1 as it is, x square by 3 factorial is 6 and minus x to the power of 5 factorial is 120 minus x to the power of 4, 2 2s are 4 and 3 factorial is 6, is it is square, 6 factorial is 36. So 1 plus x square by 6 as it is. You have to take, since the x power 4 is common in the numerator for both the terms. So what you are doing, you are taking x to the LCM in the denominator. 120 for 120 and 36, the LCM is 360 and the numerator term will be 7x to the power of 4. So what is your y of x here? Y of x equals 1 plus x square by 6 plus 7x to the power of 4 divided by 360. Hence the proof. Now let us go to the new problem. That is one more problem, that is expand log of 1 plus x by Maclaurin's expansion. So the solution. So first what do you have to do? The given function is log of 1 plus x. What do you have when log of 1 plus x? What do you do here? So what do you do here? Equate this log of 1 plus x to y of x. Y of x, first what you have to do, equate this given function to y of x. So it becomes y of x equals log of 1 plus x. So what is our next step? What you have to do? What you have to do is, since the given is expand, so here observe in the previous term here, observe here, it was in the previous question it was given that obtain the expansion of f of x divided by sin x up to the term containing x to the power of 4. When such expansion obtained, when the problem, observe the problem here, when only they are asking to expand the term x to the power of 4. Since you have the formula for x sin x, so what you will do, first you will just consider the y of x and you will be solving, and you will not differentiate here. That is, you will consider the function, given function to the as y of x, and you will substitute the formula for, as we know the formula for sin of x in terms of Maclaurin series, we will substitute the formula for sin x and we will go on solving here. Here when fraction term is given, and when you know the formula for sin x in terms of Maclaurin series, no need of differentiation. Whereas here you doesn't know the value of how to differentiate this. It doesn't know the value of log of 1 or log of 1 plus x in terms of Maclaurin's expansion. So what you will do in such a case, consider given the equation, equate the given equation to y of x equals log of 1 plus x. So here in place of x, what is our first step? So y of x changes to y of 0. Wherever x you find in this equation, substitute it to 0. Y of 0 equals log of 1 plus 0. Log of 1 plus 0 is log 1. Log 1 value is 0. Then what is the second step? After this y of x, second step is since expand is given, so what you have to do, how do you expand? By differentiating you will expand. So it means expand in the sense you have to differentiate the given function at least to the power of 4, y to the power of 4 or y to the power of 5. So y of x differentiation is y dash of x, log s differentiation is 1 by x. So what happens? 1 divided by 1 plus x. So differentiation of 1 is 0 and differentiation of x is 1. So what will y dash of 1 x becomes? Y dash of 0 equals 1 divided by 1 plus 0 is 1. Next, y dash of x, further it should be differentiated, right? Again, till at least you have to differentiate in y to the power of 4 terms. So what is your second differentiation? It will be y dash of x equals, how do you differentiate? Differentiate in terms of quotient. So quotient rule you have to use here. So what happens? First you have to write the denominator as it is, 1 plus x into differentiation of numerator, that is 1 is 0, minus numerator as it is, differentiation of denominator is 1. Differentiation of denominator, that is differentiation of 1 is 0, differentiation of x is 1 divided by 1 plus x whole square. When you simplify that, 0 into any term is 0, minus 1 divided by 1 plus x whole square. Next, after when you get y double dash of x, what is your next step? You have to show that y double dash of 0 equals, what's the value do you get here? Minus 1 divided by 1 plus, what is x here? 1 plus 0 whole square. What you will get? Minus 1. Next, further differentiation, what it says, y double dash of changes to y triple dash of x equals minus, again quotient rule, further differentiation, what it says, denominator, that is 1 plus x whole square, into differentiation of numerator is 0, minus of numerator differentiation of denominator is 2 into 1 plus x divided by 1 plus x whole to the power of 4. Y, that is 1 plus x whole square is 1 plus x whole to the power of 4. Y triple dash of 0 equals, first term will be equate to 0, minus into minus is plus, 2 into 2 divided by 2 into 1 is 1 divided by 1 plus 0, 1 to the power of 4. The answer will be 2. Next, further one more differentiation, will stop till y to the power of 4 of x. So what it says, differentiation of that is, what is the differentiation of this? Minus into minus plus 2 into 1 plus x. So what you have to do, first you have to write the denominator 1 plus x whole to the power of 4 into differentiation of numerator is 0, minus differentiation minus 2 into 1 plus x whole, that is 4 into 1 plus x whole cube divided by 1 plus x further you will get here it as 1 minus 6 divided by 1 plus x whole to the power of 4. 4 to the 8 here. Then what will be y to the power of 4 of x will be what? So y to the power of 4 of 0 equals minus 6 divided by 1 plus 0 whole to the power of 4 equals minus 6. So what is your Maclaurin's expansion? Till see here, from given function is log of 1 plus x, and you have to expand it using Maclaurin's expansion. So write the given function in terms of y of x. Y of x equals log of 1 plus x. Y of 0 equals log of 1 plus 0. Again expand the y of terms till y to the power of 4. Then after expanding, you write what you have to do now. You have to write as hence Maclaurin's expansion. What is your Maclaurin's expansion says? Y of x equals y of 0 plus x into y dash of 0 plus x square by 2 factorial into y double dash of 0 plus x cube by 3 factorial into y triple dash of 0 plus x to the power of 4 factorial 4 divided by 4 factorial into y to the power of 4 of 0 plus so on. So what is your y of x given? Log of 1 plus x. Y of 0 is what is y of x? Y of x is log of 1 plus x. Then what is your y of 0? Y of 0 is 0 plus x as it is. Y dash of 0 is 1 plus x square by 2 factorial is 2. Y double dash of 0 is minus 1 plus x cube by 3 factorial is 6 into 2. Y triple dash of 0 is minus 1. Y triple dash of 0 is 2 plus x to the power of 4 by 4 factorial is 24. Y to the power of 4 of 0 is minus 6. When you expand, what you will get? Log of 1 plus x equals x minus x square by 2 plus 2 1s are 2 3s are minus x x cube by 3 minus x to the power of 4 plus 6 1s are 6 4 x to the power of 4 plus so on. So this is the standard formula of log of 1 plus x. When you expand log of 1 plus x using Maclaurin's series, you will get x minus x square by 2 plus x cube by 3 minus x to the power of 4 plus so on. So remember this formula. This formula will be used in the further while solving the Maclaurin's other functions, when the function is given in terms of logarithm terms. See, as you have used sin x in the previous formula, previous problem, in the same way log of 1 plus x will also be used somewhere in other problems. Okay, next. Next, your function is prove that log root of 1 plus x equals x plus x cube by 3 plus x to the power of 5 by 5. So already you have see here, if the question is given and you have to prove that. So you have to prove that log of root 1 plus x divided by 1 minus x as x plus x cube by 3 plus x to the power of 5 divided by 5 plus so on. So first what you have to do, solution. First what you have to do, we have to consider we have the logarithmic series, right? We have the logarithmic series. What is your logarithmic series? What is your logarithmic series? The previously series which you have solved here. This series is called as logarithmic series. This series is known as logarithmic series. Okay, this series is known as logarithmic series. What is your logarithmic series? You have log of 1 plus x equals x minus x square by 2 plus x cube by 3 minus x to the power of 4 by 4 plus so on. After considering this logarithmic series, what you have to do is, in this logarithmic series you have to change x to minus x. Change x to minus x. Here x you have, right, this x plus x should be changed to minus x. So what it becomes, log of 1 plus x becomes 1 minus x equals minus x, minus sign as it is, minus x whole square by 2 plus minus x whole cube by 3, minus sign you keep as it is. Instead of here x, what you have to write, minus x whole to the power of 4 by 4 plus so on. After this, what you have to do is, then log of 1 minus x, solve this, minus x, minus sign as it is, minus x whole square is x square by 2, x square by 2 minus x cube, odd power, when you multiply the minus sign by odd power you will get minus x cube by 3 minus x to the power of 4 by 4 and so on. So consider this as your equation 2. Consider this as your equation 2, and log of 1 plus as this as 1 as equation 1. Now you have both equation 1 and 2. What you have to do is equation 1 minus equation 2. What is your equation 1? You have log of 1 plus x. Log of 1 plus x, minus sign as it is. What is your equation 2? Log of 1 minus x. So what it becomes? X, log of 1 plus x says x minus x square by 2 plus x cube by 3 plus x cube by 3 minus x to the power of 4 by 4 plus so on, minus of, what is your log of 1 minus x? Minus x minus x square by 2 minus x cube by 3 minus x to the power of 4 by 4 and so on. So then what it becomes here, x minus x square by 2 plus x cube by 3 minus x to the power of 4 by 4, multiply this minus sign inside the bracket, what you will get, minus into minus plus x square by 2 plus x cube by 3 plus x to the power of 4 plus so on, plus so on. So what happens?